Let's jump right in. Welcome to this explainer, where we're going to take a ton of macro-level infrastructure data and transform it into a high-yield mock interview guide for your engineering services examination. Look, if you're gearing up to face the ESE panel, you already know the deal. They want candidates who can connect the dots between granular, on-the-ground engineering principles and massive national policies. And today, we're bridging that exact gap.
So here's our game plan. First, basic engineering, specifically pavement types. Then we'll zoom out to macro projects with the Bharatmala Pariyojana. Third, railway logistics and freight corridors. Fourth, we'll hit the national logistics policy. And finally, advanced tech, focusing on ODAS. Let's get to it.
Section 1. Basic Engineering. Pavement Types. Okay, imagine you're sitting in the interview and the panel hands you this prompt. What are the fundamental differences between rigid and flexible pavements? It sounds kind of basic, right? But it's actually a trap to test your precision. Take a quick breath, structure your thoughts, and get ready to deliver a razor-sharp technical comparison. You absolutely need to zero in on two things right away: load distribution mechanics and financial life cycles. Here's the blueprint for a killer answer. You want to contrast the two directly. Talk about rigid pavement, cement concrete, right? It uses slab action to transfer loads, giving it a massive 30 to 40-year lifespan, even though it costs a lot more upfront. Then flip the script to flexible pavement, bitumen. It relies on layered grain-to-grain stress transfer. It's way more economical initially, but you're only looking at a 15 to 20-year life. Lay it out just like that. Now, if you really want to score top marks and make the panel sit up, you've got to name drop the specific classifications of rigid pavements. I'm talking jointed plain concrete pavement, JRCP, CRCP, and pre-stressed concrete. Rattling these off proves you don't just know the basics, you actually understand the nuances of how engineers manage things like temperature expansion and cracking. It's a real game changer for your score.
Moving on to Section 2, Macro Projects, Bharatmala Pariyojana. The panel absolutely loves testing your awareness of current events. So when they ask how the Bharatmala Pariyojana aims to optimize India's road network and how it's funded, you need to stay totally objective. You're impartially analyzing this flagship Ministry of Road Transport and Highways program. Don't just recite facts. Explain the why and the how. To really nail this, you have to mention the scale, because it is literally staggering. A top-tier answer points out that Phase 1 covers 34,800 kilometers across 31 states and over 550 districts. We aren't just talking about laying some asphalt here. This is about fundamentally bridging infrastructure gaps to make freight movement completely seamless across the country.
And here is where you can seriously impress them. Talk about the money. Explain that beyond the old-school engineering, procurement, and construction contracts, this project uses some incredibly innovative financial capitalization. Mention toll-operate-transfer models, where private companies maintain the roads for a lease. Bring up INVITs, which are basically like mutual funds but for infrastructure. Or talk about the hybrid annuity model, where the government actually shares the risk. It shows you understand the financial engineering driving the civil engineering.
All right, Section 3, Railway Logistics, Freight Corridors. This one is a classic problem-solution matrix. When they ask how dedicated freight corridors, or DFCs, improve operational efficiency and revenue for Indian railways, they're looking for structural engineering upgrades. How do you actually solve systemic network congestion? Your best evidence? The specs. Point out that by building these specialized, totally independent lines capable of handling a massive 25-ton axle load, transit times just plummet. Plus, they're using electric traction to handle up to 300 trains daily. This heavy haul upgrade literally drove an unprecedented 15% revenue bump for the railways in the 2022 to 2023 financial year. That is a massive return on investment. So the big takeaway here, the real so what, is that these DFCs are the essential engineering backbone needed to hit a huge national goal. The National Rail Plan Vision 2030 is targeting a 45% freight modal share for the railways, up from a much lower current share.
Let's jump to Section 4, the National Logistics Policy. How does the NLP aim to alter freight modal share and boost economic competitiveness? Again, analytical, objective evaluation is key here. Just stick to the data. Frame your answer around the cross-sectoral push to seamlessly integrate road, rail, air, and water transport. A great way to set the stage is by highlighting the current problem. Point out our overwhelming reliance on road transport. It's sitting at 65% right now, with rail lagging way behind at 27%. That imbalance is exactly what causes massive delays, crazy high fuel consumption, and just total inefficiency across the entire supply chain.
Then back up your argument with this stark contrast. Right now, India's logistics costs eat up about 13 to 14% of our GDP. The global average, about 9.5%. The NLP's target is to drastically slash our costs to below 5%. That is the exact kind of efficiency required to match and even beat global superpowers. Oh, and here's a pro tip. ESE panels absolutely love acronyms, so make sure you cleanly define ULIP, the Unified Logistics Interface Platform. It's a digital portal integrating container tracking, analytics, and benchmarking. Defining this proves you understand that modern civil engineering is now deeply intertwined with IT and data analytics. It's not just about concrete anymore. Finally, Section 5, Advanced Tech, ODAS. In the context of intelligent transportation systems, how does ODAS mitigate highway accidents? This question tests your knowledge of the latest Phase 2 initiatives from the Ministry of Electronics and Information Technology. It's honestly fascinating to see the IT sector intersect directly with traditional road construction to create intelligent systems. Start off with a bang. Hit them with this shocking statistic from the Ministry of Road Transport and Highways. 84% of accidents are caused by driver error. Think about that. When speeds increase on all these new, beautiful expressways, human error becomes the single biggest variable that engineers have to solve for. Then, lay out the solution. Define ODAS, the Onboard Driver Assistance and Warning System. It's an indigenous, radar-based tech solution. By using millimeter-wave sensors and advanced algorithms to monitor the car's surroundings, it delivers real-time acoustic and visual alerts. Basically, it actively corrects human errors before they ever turn into a collision. So, bringing it all together, if you can seamlessly bridge granular pavement engineering with macro schemes like Bharatmala, and then top it all off with digital safety tools like ODAS, you're golden. It proves to the panel that you have the exact analytical, big-picture mindset they are desperately looking for.
As we wrap up this explainer, I want to leave you with one final thought to ponder as you build your career in civil engineering. If engineering innovations like DFSEs and ODAWs continue to scale up, will bridging this gap between basic physical infrastructure and digital logistics be enough to make India the world's primary manufacturing hub by 2030? Think about it. Physical asphalt perfectly synced with AI safety systems. Could that be the ultimate formula? Thank you so much for joining me on this deep dive. Now go out there and absolutely ace that interview.